Okay, welcome back everybody. I've added some sodium sulphate, 1 mole, to the 2 tanks. I also added a little bit extra. I had 75 grams of zinc bromide left, so I mixed that up in 250 mils of liquid and put that in. And I added another 300 mils to help dissolve the sodium sulphate. So we have zinc bromide, sodium sulphate at 1 mole each. Well, the zinc bromide's probably not at a mole now because we got more liquid, but not too bad. I run a gravity cell test with these 2 plates. As you can see, the top one, the mesh is stainless steel 316, but after charging there was 2 little pieces of the stainless steel wire. One dissolved, so it dissolves stainless steel when it turns to bromine really quickly. So that's what that green color is. So in there, that stainless steel plate is being corroded slowly, and the screws which are holding that plate and the carbon pads, they're probably, hopefully they're intact, because it's about 2 weeks been sitting in there now. So it plates zinc pretty well. The zinc side's unaffected, the stainless steel. Doesn't affect it at all. It was sort of just coating onto the carbon pad. I had both of them like this, but it ate through that wire and disconnected itself, so I made a piece of the offcuts and attached it to that and charged it for an hour and dissolved again. This will be the 3rd test. I lost the results of the 2nd test. It was not that much better. It did go to 1 volt and it held 0.8 for over an hour, and then slowly went down to 0.5 and then kept running 50 milliamps at 0.01 of a volt for a while. So we'll see what I'll get ready to set up now, and we'll see what it does with some sodium sulphate in the mix. That's if all the pumps and stuff aren't dissolved, like the bearings and stuff. There wasn't a great lot of information on zinc bromide corroding stuff. There was a little bit, but it all come down to more research was required. So it hasn't, I don't think the outer containers haven't really bothered the aluminium one-way valves, but will it start is another question. So that's contaminated with nickel and chromium probably. Apparently chromium, or CR3, is a good additive for the negative tank. It helps stop zinc dendrites, so I've read. So we probably got some of that in there maybe, and whatever else is in the stainless steel going into that liquid. Connected so far at 0.3. I haven't pumped any liquid through yet, so it's all connected. All I have to do is put a charge through it, but we'll pump the liquid and check what the voltage is. I'll just connect the battery charger to the motors and I'll be back. Oh, it's going to pump when I connect it up, so if the voltage changes, that's due to its automatic pumping process when you connect the power to that speed controller. Okay, there might be a problem with the positive side pump's motor. No liquid's moving. So you watch that pipe, it's this side tank. Gets to about there and stops. It might have a blockage. Ah, bugger. One-way valve could be blocked. I'll just jiggle it around and I'll get back. Read the blockage, I put it on 52% or 3%, can't see that other thing. So we got a flow going through the cell now, both sides. So the pump's working sort of, I guess. I found 30 to 35% on the motors is a good speed for it. In the negative tank I found zinc particles at the bottom, or a grey substance, so I guess it's zinc. We're probably flowing too fast and it's removing the zinc. So the voltage didn't go up much more with liquid going through the cell. So we'll get ready for a charge. I'll try to keep the charge voltage, the amperage down, so could have been overcharging. We'll see how it goes, because this sort of draws too much for that little power supply. Okay, I've got the power connected. It's taken 700 milliamps through the cell at 2.1 volts. And we're dropping. I've got the pumps running still at 33%. So we're just under a litre on that one. That's the litre mark right there. So we're looking about 15 millimeters to go to that. So we'll see if that starts filling up. Because I think the positive side tank's pump is a bit stronger than the other pump, and that's an uneven flow and it forces it through the membrane, because the negative tank always fills up for some reason. So as the internals of this, I'm not sure if it's all intact due to the corrosive nature on stainless steel with the bromide or bromine once it's converted to bromine. So we've dropped a bit, now we're at 600 milliamps. Oh yeah. Alright, I'll charge it up for, I don't know, I've got the whole day now, what's left, it's 12:13. So I'll give it 3 hours if I can. I'll keep an eye on the liquids, but both liquids are the same colour now, because of the contamination from the stainless. So it'll be an interesting thing if that negative tank changes back to a beige colour. I doubt it. We're probably shorting out, so I'm not sure what the runs are going to be like. So here we go. The tubes are staying full, so that means the inside there is full. We're still around 699 milliamps, 700 increasing. So I'll leave that for 10 minutes and then I'll give it a purge. Okay, it's been charging up for 4 hours and 39 minutes. And we're holding 1.2 volts without the charger on it. So I'll just start the pump, so it's much higher voltage. Probably due to the sodium sulphate maybe. Okay, so we're ready for our test. Stop the monitoring and start. Okay, we've dropped down to 1.1 volts with 50 milliamp load. Have the pump set on 33%. The liquids are the same colour now due to the cross contamination when I mix the sodium sulphate. So we'll see how long we can get the cell to run for. It's actually holding its voltage well. Alright, we'll get back. Okay, I'm going to stop the test. We've got 254 milliamp hours, 174 milliwatt hours. We've been running for 5 hours. And we're down to 0.4 volts. Not a bad run. I'll continue it tomorrow sometime after work. So we'll just shut it down and see what the recovery is like. And for 5 hours we've been running the pumps at 33%. Okay, so tomorrow we'll check the voltage before we start, and we'll see how long we get extra. Okay, it's the next morning. We're sitting at 0.5 volts, so we'll continue our discharge. I haven't ran the pump yet, so I'll start that up now and get back. Pumps, and we have a raise in voltage. We're at 0.6, starting our 50 milliamp load test. Part 2 continued from yesterday's 5-hour run. Okay, we've dropped down to around about what we were last night at 0.4. Alright, we'll see how long we get extra. It's a low voltage battery, but I don't know. It does the 50 milliamps even with lack of voltage. Alright, I'll get back. Okay, we've actually drained the positive into the negative tank. It was, I don't know, about 10 mil under the 1 litre mount. And so in 5 hours it's filled up about 50 mils of liquid, so we'd be short-circuiting through that as well. Slightly paler than the positive side tank. That's much darker than that one. So it is getting paler. And it has some sort of orange like bubbles up the top. Well, that one's got clear bubbles. And the pumps are set at 33%. At least the percentage stays the same when you connect it up. Quite happy with this thing. Not bad for 20 bucks. Takes a beefy thing. It's about, I think it's about 60 amp. Okay, we got another further 3 hours out of the cell. But we only got 156 milliamp hours and 24 milliwatt hours due to the low voltage. So we can't maintain our 50 milliamps anymore. So I'll stop the test. What was that? People building a house there did something just then. So it wasn't the battery. Okay, voltage bounce back. Turn the pumps off. So in that 3 hours, we've gone under our 1 litre now, so it's pumping back into that tank. Well, they're about even. That's the 1 litre mark right above that water line. And that's the 1 metre line right above that water line, if you can see it. I'll let that sit for a while and come back and see what we've bounced back up. The motor's running. We got a slightly faster increase, but it sort of won't probably go up anymore, or a little bit more, probably goes to 0.5. So hope you enjoy this video. I'll try it again next week for another run, and then I'll strip it apart and we'll try some carbon pads with some zinc hexacyanoferrate on one side and the iron 3 on the other side, and we'll see how that goes. And I'll use the for the binder I'll use Robert Murray Smith's ink. Really what I need is to buy some of that plastic from him, which we iron on to the stainless. That should protect it. But I think his shop ran out. I'm gonna contact him and see if is he gonna make any more. So that will probably help the cell heaps. Or I could paint the stainless with some of the ink anyway. I might do that. Just a thin coat. I don't want to waste too much of the ink there. But that should be an interesting run. So it won't be the next video, it will be the one after for that lot. I'll test this again in its current state. And thanks for watching.